Welcome to COIS ADMN 1620, Introduction to Information Systems. This is Chapter 13, Acquiring Information Systems and Applications. Learning Objectives. Discuss the different cost-benefit analyses that companies must take into account when they formulate a strategic IT plan. Discuss the 4 business decisions that companies must make when they acquire new applications. Enumerate the primary tasks and the importance of each of the 6 processes involved in the systems development lifecycle. And describe alternative development methods and the tools that augment these methods. Chapter Outline. 1. Planning for and justifying IT applications. 2. Strategies for acquiring IT applications. 3. Traditional systems development lifecycle. And 4. Alternative methods and tools for systems development. Opening case. Paychex speeds development with DevOps. What we'd like you to think about here is, why is it important for new IT systems to be implemented faster? And what are the types of feedback that users, such as Paychex employees, can provide for new systems? Planning for and justifying IT applications. We're going to talk about IT planning and evaluating and justifying IT investment, benefits, costs, and issues. Figure 13.1, the Information Systems Planning Process. The basic inputs are the organization's mission and the business assessment, which is combined into the organization's strategic plan. At that point, the current information technology architecture comes into play. An IISCE strategic plan is made, new information technology architecture is determined, IISCE operational plan is implemented, and IISCE development projects begin. IT planning. We're going to discuss organizational strategic plan, IT architecture, IT strategic plan, IT steering committee, and the information system operational plan. The organization's strategic plan identifies what the firm's overall mission is and the goals that follow from that mission, and outlines the broad steps required to reach those goals. The strategic planning process modifies the organization's objectives and resources to match the changing markets and opportunities. The IT architecture defines the way that an organization should use its information resources to accomplish its primary missions. It encompasses both technical and managerial aspects of the information resources. The technical aspects include hardware and operating system, networking, data management systems, and application software. The managerial aspects specify how the IT department will be managed, how the functional area managers will be involved, and how IT decisions will be made. The IT steering committee is a critical component in developing and implementing the IT strategic plan. It's comprised of a group of managers and staff who represent the various organizational units, and it's created to establish IT priorities and ensure that the management information systems function is meeting the organization's needs. The major tasks of the committee are to link corporate strategy with IT strategy, to approve the allocation of the resources for the management information systems function, and to establish performance measures for the MIS function and ensure that they're met. The IT steering committee is important to you as it ensures that you get the information systems and applications that you need to do your job. IT strategic plan. The IT strategic plan must meet 3 objectives. It must be aligned with the organization's strategic plan. It must provide for an IT architecture that seamlessly networks users, applications, and database. And it must efficiently allocate IISCE development resources among competing projects so that the projects can be completed on time and within budget and still have the required functionality. A typical IISCE operational plan includes a mission statement of the information system function, the IISCE environment, objectives of the IISCE function, constraints of the IISCE function, the application portfolio, and the resource allocation and project management. The mission statement is derived from the IT strategy. The IISCE environment is the summary of the information needs of the individual functional areas and of the organization as a whole. Objectives of the IISCE function is the current best estimate of the goals of the IISCE function. The constraints are the technological, financial, personnel, and other resource limitations on the IISCE function. The application portfolio is a prioritized inventory of present applications and a plan that is very detailed of the projects to be developed or continued during the current year. And resource allocation and project management is a listing of who is going to do what, how, and when. Evaluating and justifying IT investment. Benefits, costs, and issues. Under this, we're going to assess the costs, assess the benefits, and we're going to conduct the cost-benefit analysis. 4 common approaches for this are net present value, return on investment, break-even analysis, and the business case approach. Net present value is a method to convert future values of benefits to their present value by discounting them at the organization's cost of funds. What that means is that we are taking the stream of cash flows in the future and expressing it in today's dollars. They can compare the present value of the future benefits with the cost required to achieve those benefits to determine whether the benefits exceed costs. Return on investment measures management's effectiveness in generating profits with the available assets. ROI is calculated by dividing the net income generated by a project by the average assets invested in that project. ROI is a percentage, and the higher the percentage return, the better. Break-even analysis determines the point at which the cumulative dollar value of the benefits from the project equals the investment made into the project. The business case approach uses a written business case to justify funding for one or more specific applications or projects. IISCE professionals will provide the input for the development of business cases, and the business cases will describe what you do, how you do it, and how a new system could better support the organization. Strategies for acquiring IT applications, first of 2. The fundamental decisions in acquiring IT applications are: how much computer code does the company want to write? How will the company pay for the application? Where will the application run? And where will the application originate? A company can choose to write all, some, or none of the application. If they choose to write none of it, that means, of course, that they're going to be purchasing the application. How will the company pay? Once the company has decided how much code they're going to write, it must decide how to pay for it. Companies can buy applications or lease them. With totally custom applications, we need internal funding in order to be able to write them. Where will the applications run? We can host them ourselves, or we can run the application on someone else's platform. We can either, therefore, employ software as a service, as a cloud vendor, or an application service provider. Where will the application originate? Pre-written applications can be open source software, or they can come from a vendor. We can choose to customize pre-written open source applications or pre-written proprietary applications from vendors, or we can customize applications in-house or outsource that customization. And then, of course, the final choice is to write totally custom applications in-house, or we can outsource a totally custom application. Purchase a pre-written application. There are many commercial software packages that contain standard features that are required by IT applications. So purchasing an existing package can be very cost effective, and it can be very time savings compared with custom development of the application in-house. Nevertheless, a company should carefully consider and plan the buy option to ensure that the selected package contains all the features necessary to address the company's current and future needs. Customize a pre-written application. Customizing existing software is attractive if the software vendor allows the company to modify the application to meet its needs. It may not be attractive in the cases where customization is the only method of providing the necessary flexibility to address the company's needs. It's also not the best strategy when the software is either very expensive or likely to become obsolete in a short time. Customizing a pre-written application can be extremely difficult, particularly for large, complex applications. Lease the application. Instead of the buying option and developing applications in-house, the lease option can save a company both time and money. Lease packages, like purchase packages, may not exactly fit the company's application requirements. However, vendor software generally includes the features that most commonly are needed by organizations in a given industry. The company has to decide which features are necessary. Application service providers, ASP, and software as a service vendors. Software as a service, or SaaS, is a method of delivering software in which a vendor hosts the applications and provides them as a service to customers over a network, which is typically the internet. Customers do not own the software, they pay for using it. It eliminates the need for customers to install and run the application on their own computers, so it saves expense, the money, time, and IT staff of buying, operating, and maintaining software. Salesforce is a great example of an SaaS provider for CRM software solutions, and it provides these kinds of advantages for its customers. Application service providers are an agent or a vendor that assembles the software needed by the enterprises and then packages it with services such as development, operations, and maintenance. The customer then accesses these applications through the internet. The ASP hosts both an application and a database for each customer. Strategies for acquiring IT applications, 2 of 2. Use open source software, outsourcing, continuous development, and employ custom development. Organizations obtain a license to implement open source software products and either use it as is, customize it, or develop applications with it. Unless the company is one of a few that want to tinker with their source code, open source applications are basically the same as proprietary application except for licensing, payment, and support. Open source software is really an alternative source of applications rather than a conceptually different development option. Using outsourcing, companies can acquire IT applications from outside contractors or external organizations. Companies can use outsourcing in many situations. For example, they might want to experiment with new IT technologies without making a substantial upfront investment. They might also use outsourcing to obtain access to outside experts. One disadvantage of outsourcing is that companies frequently must place their valuable corporate data under the control of the outsourcing vendor. Some companies outsource offshore, particularly in India and China. This is called offshoring. It can save money, but it includes risks as well. The risks depend on which services are being offshored. If a company is offshoring application development, then the major risk is poor communication between users and developers. In response to these risks, some companies are bringing outsourced jobs back in-house, a process called reverse outsourcing or insourcing. Continuous application development automates and improves the process of software delivery. In essence, a software development project is not viewed as having a defined product, with development stopped when the product is implemented. Rather, a software development project is viewed as constantly changing in response to changing business conditions and in response to user acceptance. Continuous application development is the process of steadily adding new computer code to a software project when the new computer code is written and tested. Each development team member submits new code when it's finished. Automated testing is performed and ensures that it functions within the software project requirements. Custom development is the option to custom build an application. Companies can either perform this operation in-house or outsource the process. Although this custom development process is usually more time-consuming and costly than buying or leasing, it often produces a better fit with the organization's specific requirements. Table 13.1, Advantages and Limitations of the Buy option. So the advantages are many types of off-the-shelf software are available. The company can try out the software before purchasing it. The company can save a lot of time by buying rather than building. The company can know what it is getting before it invests in the product. And Purchased software may eliminate the need to hire personnel specifically dedicated to a project. The disadvantages of the buy option are: software may not exactly meet the company's needs. Software may be difficult or impossible to modify, or it may require huge business process changes to implement. The company will not have control over the software improvements and new versions. Purchased software can be difficult to integrate with existing systems. Vendors may discontinue a product or go out of business. Software is controlled by another company with its own priorities and business considerations. And the purchasing company lacks intimate knowledge about how and why the software functions as it does. Figure 13.2, operation of an application service provider. So you can see here that the application service provider has a data center. It has separate databases and separate applications for customer A, customer B, and customer C. Figure 13.3, operation of a software as a service vendor. We can see that the SaaS vendor data center has a single application with a single database that's segregated amongst customer A, B, and C, and customer A, B, and C all have access to the same application. It's about business 13.1. Developers help dry cleaners. What we'd like you to consider here is how the global economy and the internet result in an innovation rapidly becoming a requirement. For example, Startup in 2016 was an innovation, but is not considered one now. What other IT services are new but commonplace? And how many cleaning apps are there in your neighborhood? Do they seem to be easy to use? Traditional systems development lifecycle. Systems development lifecycle, SDLC, stages are systems investigation, analysis, design, programming and testing, implementation, and operations and maintenance. Figure 13.4, a 6-stage systems development lifecycle with supporting tools. The business need drives the systems investigation, the deliverable of which is a go or no-go decision. This goes into the systems analysis. The deliverable are user requirements. We're using uppercase tools between systems investigation and systems analysis. We are prototyping starting at that point, and we move into systems design, and the deliverable there are technical specifications. We use joint application design, JAD, between that and systems analysis. We continue to use prototyping throughout these stages. We move into the programming and testing stage, and we're using lowercase tools at this point. We move to implementation and operation and maintenance, still using the lowercase tools. CASE tools are computer-aided software engineering, CASE. The uppercase tools are ones that automate the early stages of the system's investigation, analysis, and design. The tools used to automate the later stages of the SDLC, programming, testing, operation, and maintenance, are called the lowercase tools. The case tools provide links between uppercase and lowercase, and they are called integrated case or IISCE tools. Table 13.2 in the text talks about the advantages and the disadvantages of IISCE tools. Figure 13.5, comparison of user and developer involvement over the SDLC. On our x-axis, we have the stages of the SDLC, as we've just discussed, which is also time in the project. And we can see that on the y-axis, we have user development at the top and developer involvement at the bottom. So we can see that the developer is heavily involved in the systems design and programming and testing stages. Once we get to implementation, operation, and maintenance, and when we start with systems investigation, systems analysis, that is more user dependent. The traditional systems development lifecycle, SDLC team, are users, systems analysts, programmers, technical specialists, and stakeholders. SDLC, systems investigation. There are 3 basic solutions. Do nothing and continue to use the existing system unchanged, modify or enhance the existing system, or develop a new system. The feasibility study will include technical feasibility, economic feasibility, and behavioral feasibility. Technical feasibility determines whether the company can develop or otherwise acquire the hardware, software, and communications components needed to solve the business problem. It also determines whether the organization can use its existing technology to achieve the project's performance objectives. Economic feasibility determines whether the project is an acceptable financial risk, and if so, whether the organization has the necessary time and money to successfully complete the project. Behavioral feasibility addresses the human issues of the systems development project. And then the steering committee prioritizes and makes a go, no-go decision. SDLC, systems analysis. The process whereby systems analysts examine the business problem that the organization plans to solve with an information system. The deliverable is a set of system requirements, that is, user requirements. SDLC, systems design. This describes how the system will resolve the business problem. The deliverable is a set of technical system specifications that specify system outputs, inputs, calculations or processing, and user interfaces, hardware, software, databases, telecommunications, personnel, and procedures, and a blueprint of how these components are integrated. Scope creep is the phenomenon of adding functions after the project has been initiated, which endangers time frame and expenses associated with the project and expands them beyond agreed upon limits. The budget of the project and its schedule are therefore both endangered because scope creep is expensive, so successful project managers place controls on changes requested by users, and these controls help to prevent such runaway projects. SDLC, programming and testing. Programming is translating the design specifications into computer code. Testing is the process that assesses whether the computer code will produce the expected and desired results. It's also intended to detect errors or bugs in the computer code. SDLC, implementation. Implementation, that is deployment, is the process of converting from an old computer system to a new one. Conversion strategies are direct conversion, pilot conversion, phased conversion, and parallel conversion or historic parallel. Direct conversion is where the old system is cut off and the new system is turned on at a certain point in time. It's the least expensive type of conversion, but it's also the riskiest because if the new system does not work as planned, there's no support from the old system. Most systems are implemented using direct conversion. A pilot conversion introduces the new system in one part of the organization, such as in one plant or one functional area. The new system runs for a period of time and then it's assessed. If the system's working properly, then the system is implemented in other parts of the organization. A phased conversion introduces components of the new system, such as individual modules, in stages. Each module is assessed. If it works properly, then other modules are introduced until the entire new system is operational. Large organizations commonly combine pilot and phased approaches, so they execute a phased conversion using a pilot group for each phase. The last strategy, parallel conversion, is one in which the old and the new systems operate simultaneously for a time. This is seldom used today. It's very impractical when both the old and new system are online together because you would have to complete, for instance, a sales order in both systems. A variation of this approach called a historic parallel is used when real transactions are run through the new system and the results are compared with the old system before the new systems are moved in for live usage. SDLC, operations and maintenance. Systems operate while they meet their objectives. They're assessed using audits. Systems require several types of maintenance, debugging, updating, and adding new functions. Alternate methods and tools for systems development. We have joint application design, JAD, rapid application development, RAD, agile development, end user development, DevOps, and tools for system development. Joint application design is a group-based tool for collecting user requirements and creating system designs. It's often used within the systems analysis and systems design stages of the SDLC. Rapid application development is a systems development method that can combine JAD, prototyping, and integrated computer-assisted software engineering, IISCE, tools to rapidly produce a high-quality system. In the first rapid application development stage, developers use joint application design sessions to collect system requirements. This strategy ensures that users are intensively involved early on. The development process in RAD is iterative, that is, requirements, designs, and the system itself are developed and then undergo a series or sequence of improvements. Rapid application development uses IISCE tools to quickly structure requirements and develop prototypes. Users then review them in additional joint application design sessions. Agile development is a software development methodology that delivers functionality in rapid iterations, which are usually measured in weeks. To be successful, this methodology requires frequent communication, development, testing, and delivery. Agile development focuses on rapid development and frequent user contact to create software that addresses the needs of business users. End user development is an approach in which the organization's end users develop their own applications with little or no formal assistance from the IT department. While end users bypassing the IT department might make it easier for them to adopt the tools that they want to work with, this process also bypasses the security measures that the IT department is trying to enforce. These shadow IT systems can open systems to vulnerabilities and create avenues for criminals to access private company and customer data. As an employee, it's important to carefully consider adopting something that has not been approved by your organization. If your shadow IT creates a vulnerability that allows a breach, you will probably lose your job. DevOps, which is a combination of development and operations, is a practice that was first presented in 2009 and has really gained traction in the last few years. It is a form of software development that brings the developers and the users together throughout the entire process with the goal of reducing the time to deployment, increasing the usability of the finished product, and lowering the cost of new app development. Tools for systems development will be covered in the next couple of slides. Figure 13.6, a rapid prototyping development process versus the SDLC. We have the traditional development on top. On the bottom, we have the compression from the analysis, design, program test, implementation of the rapid prototyping development, iterative development cycle, starting with determining the requirements, designing, developing, testing, user review, joint application design, and cycling again, iteratively until the product is finalized. Tools for systems development. Prototyping, integrated computer-assisted software engineering tools, IISCE and CASE, uppercase, lowercase. Component-based development, object-oriented development, containers, and low-code development platforms, LCDPs. In prototyping, the approach defines an initial list of user requirements, builds a model of the system, and then refines the system in several iterations based on users' feedback. Developers do not try to obtain a complete set of user specifications for the system at the beginning, and they do not plan to develop the system all at once. Instead, they quickly develop a smaller version of the system known as a prototype. The prototype can take two forms. In some cases, it's only the components of the new system that are of most interest to the users. In other cases, it is a small-scale working model of the entire system. Integrated computer-assisted software engineering tools. Computer-aided software engineering, CASE, refers to a group of tools that automate many of the tasks in the SDLC. We've talked previously about the uppercase and the lowercase tools, and that the integrated case tools are the links between the uppercase and the lowercase. Component-based development uses standard components to build applications. Components are reusable applications that have generally one specific function, such as a shopping cart, user authentication, or a catalog. Compared with other approaches, the component-based development generally involves less programming and more assembly. It's closely linked with the idea of web services and service-oriented architectures, which you've seen in Technology Guide 3. Object-oriented development is based on a different view of computer systems than the perception that characterizes traditional development approaches. The traditional approach can produce a system that performs the original task but may not be suited for handling other tasks. This limitation applies even when the other tasks involve the same real-world entities. A billing system, for instance, will handle billing, but it probably cannot be adapted to handle mailings for the marketing department or to generate leads for the sales force. This is true even though the billing, marketing, and sales functions all use similar data, including customer names, addresses, and purchases. In contrast to the traditional approach, an object-oriented system begins not with the task to be performed, but with the aspects of the real world that must be modeled to perform that task. In our example, if the firm has a good model of its customers and its interactions with them, then it can use this model equally well for billings, mailings, and sales leads. Containers are a method of developing applications that run independently of the base operating system of the server. Containers allow application providers to develop, test, and deploy technology that will always run in practice exactly like it does in testing. This would allow software to be developed more rapidly. Primarily, they provide a level of portability that has brought about one of the biggest shifts in application development in many years. Low-code development platforms make use of virtual interfaces to develop applications rather than traditional procedural hand coding. This allows for more rapid app development because it reduces the amount of code that has to be written, and an expansion of those who can contribute to a project. LCDPs allow non-technical users to provide input and efforts into app development. It's about Business 13.2. Condominium access codes are not secure. Buy a bicycle lock. What we'd like you to consider here is whether and how software could be used to manage and protect your home, and what type of security or access controls should be included in such software. Closing case: customization payroll disaster at the Government of Canada. What we'd like you to think about here is, what are some of the types of calculations that occur and would need to be tested during payroll processing? And how might duplicate payments arise during the payroll processing cycle? How could they be prevented? That brings us to the end of this chapter's lecture. Thank you for your attention.